Hello, I'm Paul Beckwith, and in this video I'm going to talk all about tipping points. Years and years ago, when I started talking about abrupt climate change, that was long before that term was even being used by other scientists to describe what was presently happening to our climate. I basically was looking, researching nonlinear physics, the physics of systems, how they can change non-linearly. I mean, the best example of the tipping point is still, I think, the canoe, where, you can rock it from side to side and feel relatively stable. And then if you reach a point where it's right on the edge of going over and tipping you into the water or self-correcting, there's a critical slowing down of frequencies, and you kind of think, okay, this is it, I'm right on the edge. I mean, that's the perfect example. Another example is, if you're cutting down a tree, dead tree, of course, it's died from Dutch elm disease or bark beetles for pine trees, then when you're cutting it, there's vibrations of the tree, and when you reach a point where it's about to go over, another little slight cut with the saw and it's going to go over, that's a critical point, and it's often an irreversible point, a point of no return, if you like. You cross this critical threshold and then you tip over into a different state. I've got both a cat, Shackleton, and my dog, both sitting next to each other watching me. I guess they want to be in the video as well. I'll get them in a video soon. Actually, you haven't seen Shaq for a while. Let me just grab him. Just give me a second. Here he is. Oh. Okay, whoops. Whoopsie. Where he is, and now I'm going to make the dog jealous. So here's Shackleton. Yes, Shackleton the Explorer. So Shackleton, I have to give him a little bit of medication in his ear twice a day at meals, because he's just a little tiny guy, and I went to the vet. Turns out he's got some hyperthyroidism, so he gets this medication to correct that, and he's gained some weight. I mean, he's always eating. He eats twice as... I have a problem because when I feed him, I have to feed the dog, and I have to feed the other cat. And the other cat's like super heavy now, and anyway, look at the camera. He's a bit camera shy today because he hasn't been on for a while. And he's got a jealous dog right here. So let me just, he's not exactly a lap dog, but here he is. Here's the Newton, Sir Isaac. Look at the camera, doggy. And anyway, yeah, he's great dog. He's about 56 pounds, or that was a couple of weeks ago. Eats like crazy, very, very sociable, loves running around, and say hi to everybody. Do you want to bark? Whoa! Oh, there we go. We get a lick from him. He gets walks twice a day in the doggy park, where he chases after all of these other dogs. And it's funny, the other day, this woman on a wheelchair with a small poodle motors around the park. And, the other dogs are all playing with her dog. Everything's good. Then she picks up her dog, and I guess she wants to continue motoring. And the big dogs were, they liked the little dog she had. So some of them were jumping up, and they were getting in her way. So she got annoyed, and she said, I'm going to restrain your dogs, or I'm going to get out the pepper spray, right? So pepper spray in a doggy park? Well, really. Anyway, so I'm talking about tipping points here. And in 2008, Lenton wrote a famous paper with other people, and they got expert analysis. Well, the experts at the time in different areas talked to, they had a conference, I believe, and a paper was published as a result of the conference. It was all on tipping points like Amazon rainforest or sea ice or Greenland ice sheet or the permafrost. And they tried to estimate a temperature threshold when each tipping point would be reached. at, and also duration, how long would it take to tip from one state to another, etc. And they wrote this classic paper, and I'll show you some of the images and charts from that paper. But anyway, so I'm talking about a new peer-reviewed paper that came out just within the last month or so that reassesses all of the tipping points and all of the papers written on tipping points. And I'll discuss those, that paper in great detail. So let me get right into it here. So this is an image from the paper. So what it has is, what you see is along here, okay, Greenland ice sheet, West Antarctic ice sheet. These are all the tipping elements of the climate system that were identified. This is the temperature, where we're at. Current warming is at 1.1 degrees Celsius, and that's based on the temperature that's relative to a baseline of 1880 to 1910. Now remember, to go back to a baseline of 1750, which was originally the pre-industrial baseline, you need to add 0.2 or 0.3 degrees to this number. This is the, in gray shaded here is the 1.5 to 2 degrees guard band. And then above here is temperatures. So this is for each of these elements. This is the minimum estimate where the system can tip. This is a central centroid, if you like, and the maximum estimate. So tipping is possible here, likely, very likely here. This is for all the elements. So we're already there for Greenland ice sheet, West Antarctic ice sheet, low latitude coral reefs, and the boreal permafrost, abrupt thaws of the boreal permafrost. Remember, abrupt change is when a small perturbation can send you into, massive response, massive changes. So another analogy, I talked about the canoe or the tree, cutting down the dead tree. Another one is, imagine a ball on the top of a hill, and in every direction you look, it's down. You're at the very peak of the hill. So a little nudge of that ball and it can go shooting off down the hill. So that would be a good analogy to a tipping point. You're in an unstable equilibrium. If you go away from that equilibrium in any direction, you start accelerating away from the point, and then you go down into the valley. You can consider the valley as an attractor, which is attracting the state. So the state wants to change from the state we're at the top of the hill to the state in the valley, and that reaches another equilibrium, but that would be a stable equilibrium. Yeah, okay, so then we've also got the, as you go up slightly higher in temperature, we have loss of Barents Sea ice, which is crucial for climate in Asia, for example. Labrador Sea, the southern polar gyre, the Labrador Sea, that's also, very close to being reached at the minimum point. Extrapolar alpine glaciers, so alpine glaciers that are not at the North or South Pole. Sahel, Western African monsoon tipping. As temperature rises, the East Antarctic subglacial basin, so the basins, the ice on the coastlines of East Antarctica. The Amazon rainforest, of course. We're undergoing Brazil elections right now. If Bolsonaro gets in again, it's like the death knell of the Amazon rainforest. Boreal permafrost collapsing. The Atlantic meridional overturning circulation. The AMOC, or THC, thermohaline concentration, ocean currents, major ocean current systems. Boreal forests in the south region, right? So as we get a warmer and warmer planet, the boreal forests in the south, it's too hot for them to grow. They die off. The forest moves to the north. So you get an expansion in the north, decline or dieback in the south. Arctic winter sea ice and East Antarctic ice sheet. So I think this is way too high for Arctic sea ice. But anyway, and then we have the different pathways, the shared socioeconomic pathways, the SSPs, And this is the equivalent of warming, so 8.5 watts per square meter. You know, this is business as usual right now, the red curve pretty much. This is a historical change. And so you can see the temperatures under these different scenarios. We're nowhere near here or here or here even. You know, we're at the 8.5. This is where we're heading. We need, the Paris range is here, net zero policies here, and current policies here. I mean, current policies, we're gonna hit 4 degrees. And this is cumulative. This is the potential thresholds that you cross, cumulative per decade. So, you know, we're crossing all of these different thresholds, time from 2020 here, and you can see that cumulatively the risk of crossing thresholds gets larger and larger. So this is from this peer-reviewed paper, which just came out by Armstrong, McKay, et al. Lenton is one of the authors, Rockstrom, you know, very famous authors. This is a summary, and this is the actual paper. So I'm going to go into detail on this paper right now, but before then, I just want to show you, this is Lenton's 2008 paper. So just Google the title, Tipping Elements in the Earth's Climate System. And he did, so this is based on a conference of experts at the time, and they looked at the different tipping points, and they plotted it versus population density on the planet to try to see how many people would be affected. And then they broke it down here. So all of these things are, most of these things are covered, but there's a few that aren't there anymore, like the Arctic ozone. You know, ocean anoxia is definitely happening. The methane hydrates, they're not discussed too much. You know, they're talking about the permafrost and tundra thawing, but not so much the hydrates on the seafloor. Permafrost tundra, Antarctic bottom water, boreal forest, they've separated that into the forest dying off in the lower latitudes and then growing in the higher latitudes, Amazon rainforest, the monsoon, West African monsoon, the Sahel, Indian summer monsoon, ENSO is in there too. So some of them appear here in the original 2008 paper, and they're not considered so much important in the most recent paper. This is not behind a paywall, but the other paper, I believe, is behind a paywall. Okay, so this is the the media article saying world on brink of 5 disastrous climate tipping points. Okay, let me just get rid of this here. Okay, so this is a Guardian article that came out less than about 3 weeks ago or so, saying giant ice sheets, ocean currents, and permafrost regions may already have passed the point of irreversible change. So we're on the brink already of multiple disastrous tipping points, according to this major study, this peer-reviewed paper, which I'm going to show you in detail. Shows 5 dangerous tipping points may already have been passed due to the 1.1 Celsius of global heating caused by humanity to date. And remember, you need to add 0.2 or 0.3 if you want to take this relative to a baseline of 1750. So that would be 1.3 or 1.4 already. So these tipping points are the collapse of Greenland's ice cap, collapse of the AMOC in the North Atlantic, or even the Labrador Current they might be talking about more, disrupting the rainfall on which billions of people depend on food, talking about the monsoons being disrupted, an abrupt melting of carbon-rich permafrost causing methane increase and also carbon dioxide increase, and darkening of the Arctic causing even more heating. At 1.5 Celsius of heating, the minimum rise now expected, to be passed very soon, maybe in a decade. 4 of the 5 tipping points move from being possible to likely, okay, not just possible, but they become likely. At 1.5, there's an additional 5 tipping points becoming possible, including changes to the vast northern forests, the taiga or boreal forest, and also all mountain glaciers, so non-polar mountain glaciers, so the glaciers that are not in the Arctic or Antarctica. In total, there's evidence for 16 tipping points, with the final 6 requiring global heating of at least 2 Celsius to be triggered. The time scales vary from a few years to centuries for these tipping points to be enacted. The Earth may have left a safe climate state beyond 1°C global warming, was the conclusion of this new peer-reviewed paper, with the whole of human civilization having developed in temperatures below this level. Now, you have to remember that when you pass one tipping point, it is likely to accelerate the change of temperature and effects on environmental ecosystems, etc. And that's likely to trigger other tipping points. And then we talk about a cascade of tipping points or self-reinforcing feedbacks. This is still being studied and is not included in this paper. So the analysis that I'm going to show you from the paper is probably the minimum danger. Professor Johan Rockström, the director of the Potsdam Institute for Climate Impact Research, and I'm hoping that he attends the COP conference, which, you know, I'm going to be attending COP27 in Egypt. It's 2 weeks, and it's beginning November 6th, running for 2 weeks. And I have a separate GoFundMe to try to raise some funds to cover my airfare and accommodation, etc., my travel, which is all, you know, from my own money. I get no funding for any of this work for these videos or conferences, etc., except from the, you know, my donations to my PayPal, which is you can find on my website here, paulbeckwith.net. I took a bit of a sabbatical, as I mentioned, and I'm back, probably a video every day or two up through the conference, because I have a lot of preparation to do for the conference. So I talked about all of the hurricanes wreaking havoc in our climate-fueled world, and there's the GoFundMe, and there's a link to it right here. Go to COP27 UN Climate Conference. So please considering donating to support my channel or to fund specifically some of my air travel to the conference. Now, I need to find back the article here. Okay, so the risk of climate tipping points is rising rapidly as the world heats up. So this is the estimated range of global heating needed to pass tipping point temperatures. Now, when we talk about tipping points or in the literature, it's mostly, so it's based on temperature, right? But there's lots of other factors in the climate system, environmental factors, factors of habitability of flora and fauna, plants and animals. McPherson worked with some other people, and they have a paper fairly recently out on that. And I'll talk about that in a separate video soon. But anyway, so this is the present warming, 1.1 Celsius. This would be the 1.5 to 2 degree band here. And this is the central estimate is the circle. And here is the, in terms of what tipping points are likely to occur first. So Greenland ice sheet collapse, you know, is a huge problem because that's 7 meters of sea level rise. You know, it would take a while for the to lose the Greenland ice, but there's lots of feedbacks. For example, as the ice melts off, the glacier, the top of the glacier is at lower elevation, so it's warmer, so you get more melting and even increased loss. So that's one of the, you know, there's lots of different connections between the different systems. West Antarctic ice sheet collapse, that's about 5 or 6 meters of sea level rise just from that alone. Of course, if Greenland collapses and you get lots of calving and rapid sea level rise, and then that undercuts the West Antarctic ice sheets, and they can collapse more, especially the ice shelves along the coast. Tropical coral reef die-off. You've heard about the reefs that are being decimated in the Caribbean, also in Australia, the Great Barrier Reef. The die-off is happening very quickly. It's probably going to be all over at 2 degrees. There'll be no coral reefs in tropical regions. And, you know, fish spend, about a quarter of the world's fish spend at least part of their life on coral reefs, usually when they're young, after they've spawned, and, you know, they use the reef for shelter. It attracts other food sources, other fish for them. You know, it provides the protection. It's shallow water. It's a huge ecosystem. It's like the it's like the Amazon, it's like the rainforest of the ocean. So we're losing the rainforest of land and losing the equivalent rainforest of the ocean. And they produce huge amounts of oxygen for us. We've got the northern, and you know, it's not just dying from water temperature being too hot. The polyps leave the coral, the reef bleaches, turns white, and if the water temperature doesn't drop quickly, then the polyps don't go back and the reef dies and it becomes replaced by algae, etc. So this is a huge problem. Just have to adjust my camera up a little bit. Have to get annoyed at the editor or at my, which I don't have, just do these things all myself. Northern permafrost, abrupt thaw. You know, this is already happening. The Arctic is warming 4 to 5 times faster. High Arctic even 7 or 8 times faster than the global average temperature. And I've explained the reasons why, albedo feedbacks, etc., etc. But the Arctic is becoming a darker place. You know, a series satellites, you know, satellite-based sensors out in space measure the reflectivity of the Earth. And for the Arctic, it's the reflectivity of the Earth was about 52% for the Arctic, and now it's about 48%. That was after a change of a space of about 10, 20 years. So the Arctic is getting a lot darker. It's absorbing more solar energy and warming. And also the snow cover over the land is vanishing quickly in the spring. That uncovers the dark permafrost underneath and greatly contributes to the thaw rates. Boreholes through the permafrost going deep down show a warming at all levels. Deep under the ground, we're getting a lot of warming. You know, this is a very, very serious issue. The Barents Sea ice loss is you know, expected to rapidly decline. This is part of the Atlantification of the Arctic, where warm water from the northern Atlantic is infiltrating into the Barents Sea, and the ice loss is extremely rapid there. Further down, the Labrador Sea Current, the gyres, is collapsing. So the AMOC collapse can be considered in 2 parts. You get the Labrador Sea Currents collapsing, which is the northern branches of the AMOC, and then the southern branches also can then collapse. The currents can slow, and that has a huge impact of cooling in Western Europe and Eastern Canada. Mountain glaciers loss. Glaciers are receding around the world. It's only accelerating, and as temperatures rise, we could lose them all. The West African monsoon shift could become a huge problem, and this has a huge negative impact to growing crops. East Antarctica glacier collapse, you know, probably about 2 degrees, we start getting a collapse of the main glaciers on East Antarctica. And there's incorporated into that, you know, 55 meters of sea level rise. So if we lose all the glaciers on the planet, we're talking about a world with about 70 or 72 meters of sea level rise. Multiplied by 3.3 times 70, you get 210 plus 21, 70 meters times 3.3, 233 feet or so of sea level rise. Imagine that. Imagine the coastlines with that type of sea level rise. You know, we get a 50-meter storm surge in Fort Myers from the Hurricane Ian, and look at all the catastrophic damages. We're talking about no cities on the coastline existing at all. You know, huge major cities being underwater with this type of situation. Amazon rainforest dieback, I have to disagree with this. I mean, there's huge dieback now. We're getting major droughts in subsequent years. You know, Brazilian government is devastating the rainforest. And hopefully that slows down if we get a left-leaning government. But, you know, the first phase of the election was yesterday, and, you know, we do have to go into a second vote in a couple of weeks because the right-wing Bolsonaro got a lot more votes than the polls showed. So if he gets in again, goodbye Amazon rainforest. This is probably going to be moved back to present day. Northern permafrost collapse here. This is the AMOC Atlantic current collapse, and this goes back to here. Like this is already considered well underway and has slowed down significantly, but there's a huge range here, a lot of uncertainty in this parameter. Northern forest dieback in the south, okay? So as we get warmer and warmer conditions, plants and animals migrate towards the poles. So in the northern hemisphere, they move northward. So the trees at the southern border of the northern forest die back and they expand at the northern border. And this expansion can actually be quite quick. So parts of Siberia that were nothing more than shrubs or plants a few inches high, within about a decade, now there's 6 foot, 8 to 10 foot trees, larch and other northern forests just appearing where they weren't before. Arctic winter sea ice collapse. I have to disagree with this number because it's very, very high temperature when they're projecting that would collapse. And East Antarctic ice sheet collapse. I mean, look at this number. It's what, it's absurdly high. I mean, it's 4 degrees or something, on the scale. Anyway, there's no question, the Earth is on a course to cross multiple dangerous tipping points that will be disastrous for people around the world. To maintain livable conditions on Earth and enable stable societies, we must do everything possible to prevent crossing tipping points. It's really worrying. There are grounds for grief, and there are also still grounds for hope. The study really underpins why the Paris Agreement goal of 1.5 is so important and must be fought for. Now, we're going to overshoot it, but we got to slash emissions. We got to remove carbon from the atmosphere. And, once we overshoot it, we got to get down below it as soon as possible, or we're going to head through these tipping points and go into catastrophic losses, which are, if you think today's bad, you ain't seen nothing yet. We're not saying that because we're probably going to hit some tipping points, everything is lost and it's game over, according to McKay, Dr. David Armstrong McKay at the University of Exeter and he's a lead author, and the other people. Every fraction of a degree that we stop below 1.5 reduces the likelihood of hitting more tipping points. Recent research has shown signs of destabilizing in the Amazon that would have profound implications on global climate and also global biodiversity. Greenland ice sheet, Gulf Stream currents. Now, the IPCC, they said that the risk of triggering climate tipping points becomes high with 2 Celsius of global warming. But this analysis in the journal Science, this paper, assessed more than 200 previous studies, and it identified 9 global tipping points that are, most concerning. That's the collapse of Greenland, West Antarctic ice sheet collapse, East Antarctic ice sheets on the coast, and also starting in the central ones, partial or total collapse of AMOC. So the partial would be the Labrador Current gyre collapsing, and then the total collapse would be the whole thing. Amazon rainforest dieback, permafrost collapse, winter sea ice loss in the Arctic. So sea ice loss year-round. Now, there's, with the Amazon, the assessment of the Amazon tipping point did not include the effects of deforestation. Not sure why. I guess they didn't know how to do it. The combination of the warming and the deforestation could bring that a lot sooner. So depends, the Brazil election is crucial for determining the fate of the Amazon rainforest and by extension the fate of the planet. Further 7 tipping points would have severe regional effects. So they divided tipping points into global effects and regional. So some of the regional are the die-off of the tropical coral reefs, changes to the West African monsoon. Other potential tipping points still being studied include loss of ocean oxygen and major shifts in the Indian summer monsoon. So the tipping points are defined as possible when its minimum temperature threshold is passed, likely when the central threshold is passed. Of course, you always need more research to try to narrow down these critical temperature thresholds, early enough so that you can do something about them, hopefully. The science of tipping points is far from done. It's barely begun. Much better models are needed to address the question of what warming level is critical for which tipping point. Now, the Swiss government proposed back in May of this year that a special IPCC report be generated solely on climate tipping points. So if they're doing that or not, I'm not sure. So Tim Lenton is a co-author from the University of Exeter, Professor Tim Lenton, and that's the paper I first showed you. He first assessed the tipping points in 2008 based on the conference, and the list has grown and the assessment of the risks has changed. So this new work provides compelling evidence that the world must rapidly accelerate decarbonizing the economy, and to do that, we need to trigger positive social tipping points. So I've talked about human tipping points being required to address the climate catastrophe. Okay, so let's go spend more time now on this paper. Okay, I'm going to go through this paper. So exceeding 1.5 Celsius global warming could trigger multiple tipping points. So this is a new paper that was just published in the last month or so. And this is the summary, article summary, okay? So climate tipping points are, so first of all, they're a source of growing scientific policy and public concern, okay? So let's have a look at the map here. So with less than 2 degrees Celsius warming, these are the global warming thresholds. Less than 2 degrees Celsius, you can start getting tipping in a number of different systems. 1, 2, 3, 4, 5, 6. And those are the boreal permafrost. Okay, so abrupt thawing of the permafrost, releasing methane, CO2, causing the Arctic to be darker, greatly accelerating warming. The Labrador Sea / subpolar gyre. So this is the lower. We got the AMOC here, and there's an upper branch of the AMOC. So if this Labrador Sea subpolar gyre shuts down, then the AMOC circulates to much lower levels. Europe and North America, along the coastlines, greatly cool. Greenland ice sheet collapse. Of course, that can raise sea level 7 meters, with instability on the coastlines, lots of calving, marine ice sheet instability. Huge melting from above, lowering the elevation with that elevation feedback, melting, loss of the ice shelves, like unleashing the cork, so the glaciers on land melt quicker and get calved into the sea. Barents sea ice loss, huge impact on the jet stream, waviness, etc. Low latitude coral reefs dying off here at the Great Barrier Reef, and West Antarctic ice sheet collapse. So we've already reached the minimum temperatures of those. Now, from 2 to 4 degrees, there's some more thresholds are crossed. 4 in particular. One is the East Antarctic subglacial basins. Okay, so on the coastlines of East Antarctica, some of the big glaciers they're sitting on the sea bottom. Pinned on the sea bottom, which is a retrograde slope. So as more melt happens, they can collapse quickly. Mountain glaciers around the world, losing mountain glaciers. Amazon rainforest dieback here. And I think this one belongs in less than 2 degrees for sure. The Sahel, West Africa monsoon, greening of the desert parts here. Those are reached with 2 to 4 Celsius, and then above 4, there's another 1, 2, 3, 4, 5, 6. So there's a total of 16. So East Antarctic ice sheet collapse, huge sea level rise problem, boreal forest, southern dieback extensive, and northern expansion extensive. The boreal permafrost collapse. So instead of just an abrupt thaw, it collapses, so it's more of a continuum than just a threshold. Arctic winter sea ice collapsing, so not just summer sea ice, but the winter sea ice. And the boreal forest, I talked about that one. Okay, some of the things like the summer Arctic sea ice, they're not considered so much a tipping point because they're ongoing and they're linear. They seem to be more linear with temperature rise. So anyway, so those are the things. So they call them the CTPs in this paper, climate tipping points. They occur when change in large parts of the climate system, known as tipping elements, they become self-perpetuating beyond a warming threshold. So once you pass the warming threshold and start the tipping, they occur on their own. They're self-perpetuating. Triggering CTPs leads to significant policy relevant impacts, including substantial sea level rise from collapsing ice sheets, dieback of biodiverse biomes such as the Amazon rainforest and warm water corals, carbon release from thawing permafrost. Okay, so Lenton identified a bunch originally in 2008. Okay, and I showed you that paper. So that's the tipping elements in the climate system. Here's the tipping elements, and here's a chart of all of the critical values, the warming required, the duration of the tipping, key impacts, etc. Okay, so again, this paper is an expansion of that. Additional tipping elements have been proposed, like parts of the East Antarctic ice sheet. The status of others, like Arctic summer sea ice, has been questioned as being whether it's tipping or not. If it's, observations have revealed that parts of the West Antarctic ice sheet may have already passed a tipping point. Potential early warning signals of the Greenland ice sheet, the AMOC, the Amazon rainforest have been detected. Multiple abrupt shifts are found in climate models when you run them. Recent work has suggested that up to 15 tipping points are now active, actually 16. Okay, so they separated the tipping points into global or core tipping elements that contribute substantially to Earth system functioning, and 7 regional impact tipping elements. They contribute substantially to human welfare, but they're not so much a global thing. They estimated the thresholds with temperature for each of those. The current warming of 1.1 above pre-industrial lies within the lower end of 5 of these tipping points. 6 of them become likely, with a further 4 possible between the range 1.5 to 2. And there's 3 other ones that are possible. An additional 1 becomes likely, and another 3 possible at the 2.6 Celsius of warming expected under current policies. Okay, so that's why climate change is an emergency. That's why we need urgent action to mitigate climate change, because when we start crossing all of these tipping points, we're going to go into irreversible change, and it can be taken out of humans' hand, our agency to do anything to affect climate, it will be severely reduced. The only thing we'll be able to have a chance at doing is solar radiation management and carbon dioxide removal from the atmosphere using technologies. So the Paris Agreement of limiting warming to well below 2, preferably 1.5. 1.5 is not safe. As we get to 2, as we get ever and ever higher temperatures, we cross more and more tipping points, and these things can then cascade. So we're heading to 2 to 3 degrees at best, so they'll be crossing all of these tipping points, and life will become very risky on this planet, much worse so than present day. So this is a key image. Now, this is the paper. So I think what I'll do is I'm going to separate this. I want to go into this paper in great detail. I'm already 38 minutes into the video, so this will be, I'm going to separate this video into a part 1 and a part 2 just to make it easier to view, but I'll try to post both of them. I'll post the second part probably within a day of the first part. So thank you for listening, and please tune in to part 2, where I just talk solely about this, this new peer-reviewed research article on tipping points. This is very important for climate, very important for society, very important for our ability to have a decent life on this planet, to survive, and also crucial for biodiversity and all the flora and fauna on the planet. So thank you for listening, and I'll go into more details in the next video. Bye for now.